Okay, so this is going to be the last question in this in our tutorial. Okay, for consistency, let me write it down. Okay. Uh, um, 5 examples. So this is going to be our third question in this tutorial. Okay. So the question says basically the same as the previous two. Use Gauss's method. Oh, sorry. Use Gauss method to decide on the type of solution of the following system. Okay, and our new system is we have minus x plus 2y plus z plus w equals to 3. We have 2x minus 2y plus z minus w equals to minus 10 minus x plus 4y minus z plus 2w equals to 14, and we have x plus 2y plus w equals to 4. Let me check just to make sure that you have written down the equations properly. Minus x plus 2y plus z plus w3. Yes. Okay. So also in this question, yeah, I will go a bit faster than the previous one. But here I'm going to do the operations again here. But from now on, or after this question, I will no longer show the operations. Okay, I'm going to show the operations just to make things clear, since this is our first encounters to Gauss's method. Okay, so yeah, I want to recopy the system. Let me do it straight away here. In that case, let me do the operations. Will I have enough space here? Yeah. No, then no. I'm trying the best way. Okay, so maybe let me do the operations below somewhere here. Yeah, so that I can have plenty of space. So let me do the operations here. Operations here. So as we have seen previously, what are we going to do? We pick the first row. The leading variable is x. Okay, so we are going to use that this whole term in x to eliminate the 2x in row 2, the minus x in row 1, in row 3, sorry, and the x in row 4. Is that okay? So that's our goal. Now let's use the Gaussian operations to accomplish our goal. So operations here, I'm going to, how do I eliminate the 2x in row 2? Is to multiply row 1 by 2. So if I multiply minus x by 2, then minus x plus 2x is going to be 0. Is that okay? So I'm going to go a bit faster. So 2 times row 1 is going to be minus 2x plus 4y plus 2z plus 2w equals to 6. And row 2, I'm just going to copy it. So row 2 is 2x minus 2y plus z minus w equals to minus 10. So we are going to have 2y plus 3z plus w equals to minus 4. This is minus 10, okay? Let me write it properly. So minus 10. This is going to be our new row 2. Let me continue with the operations, okay? So the second operation is going to be here. Now let me use minus x to eliminate minus x in row 2, in row 3. Okay, so what do? I have minus row 1, which is equal to x minus 2y minus z minus w equals to minus 3, and row 3, which is going to be equal to minus x plus 4y minus z plus 2w equals to 14. Okay, so I have here 2y minus 2z plus w equals to 11. That's going to be our new row 3. Is that okay? And let me do the third operation here. I have I'm going to use the minus x in row 1 to eliminate the x in row 3. Okay, so I don't have to do anything to row 1, so I have to recopy row 1. We have minus x plus 2y plus z plus w equals to 3, and row 4 equals to x plus 2y plus w equals to 4. So we have a 4y plus z plus 2w equals to 7. This is going to be our new row 4. Is that okay? So, okay, first of all, what have we done is to be able to get our new row 2, we have done 2 times row 1 plus row 2. That's the first Gaussian operation. Then what have we done here? We have minus row 1 plus row 3. And then what have we done? The third operation here is row 1 plus row 4. Okay, so it gives us our new system. Okay, we have to rewrite the row 1 because we haven't changed row 1. We actually use row 1 to changes to the other rows. So minus row x plus 2y plus z plus w equals to 3. So our new row 2, we say it is equal to 2y plus 3z plus w equals to minus 4. Our new row 3 is 2y minus 2z plus w equals to 11. And our new row 4 is 4y plus z plus 2w equals to 7. So that's how we have successfully eliminated the x's in row 2 and row 3 and row 4 by using the x in row 1. Okay, so now let's continue with the operations. Ooh, we don't have enough space. So maybe I will do it somewhere here. Okay, let me get rid of these word operations and put operations. So maybe let me do the fourth operation here. The fourth, now we are going to use the y in row 2 to eliminate the y's in row 3 and in row 4. Okay, so to be able to eliminate this, okay, to eliminate the y in row 3, I'm going to multiply row 2 by -1. Okay, so minus row 2, I hope you can follow. Okay, minus row 2 is equal to minus 2y minus 3z minus w equals to 4. And recopy row 3, our new row 3 of course, which is going to be 2y minus 2z plus w equals to 11. So we have um, yes, we have minus row 2, yes, and row 3, so we have 0, we have minus 5z equals to 15. Yes, minus 5z equals to 15. I hope so. Okay. Yeah. Equals to 15. And so this is going to be our new row 3. Okay, this is going to be our new row 3 here. Somewhere here. Okay, and let me write as we go on. So we have, I have done here minus row 1, row 2 plus row 3. We said it is equal to, okay, so here minus x plus 2y plus z plus w equals to 3. I hope I will have enough space because I want to do everything on the same line. I'm not sure. I don't think I will have enough space, but hey, let's go. So we have 2y plus 3z plus w equals to -4. Okay, so we changed. Our new row 3 is minus 5z equals to 15. Is that okay? And then our fifth operation here. Let's do the fifth operation here, which is we are going to use row 2 to eliminate the y in row 4. So we have minus 2 times row 2. Okay, we are working with this new system. Okay, which is minus 4y minus 6z minus 2w equals to 8. And row 4, we have 4y plus z plus 2w equals to 7. So we have minus 5z equals to 15. I hope everything is fine. So this is going to be our new row 4. So let me write it here. Our new row 4 is minus 5z equals to 15. And okay, so maybe I'm going to go to the top. Okay, just 1 second. So yeah, I'm going to, so okay, so what have I done to get row 4 here? I have done minus row 2 plus, oh sorry, here, minus row 2 plus row 4, minus row 2 plus row 4. Okay, is equal to that. So this is our new system. Now what we have to do is to use the z in row 3 to eliminate the z in row 4. Is that okay? So yeah, that was my problem. I don't have enough space. So basically what I have to do here is let me write it which way. Let me so let's go so let's go this way. Okay, so what have I done is how, how am I going to eliminate the z in row 4 is let me do the operation here. This is my 6th operation. So to be able to eliminate the z, the 5 minus 5z in row 4 is to multiply row 3 with the minus. So minus row 3 is equal to 5z equals to minus 15, and row 4 we write this, we just recopy it, minus 5z equals to 15, so we have 0 equals to 0. Okay, so I'm going to write it here. So here we have a minus row 3 plus row 4. Okay, will give us the following final echelon form system. So we have minus x plus 2w plus z equals, plus 2y. What am I saying? Minus x plus 2y plus z plus w equals to 3. The second equation, you have 2y plus 3z plus w equals to minus 4. The third equation is minus 5z, okay, equals to 15. And the fourth equation, that's our sixth operation, we have 0 equals to 0. So this is our echelon form. It is in echelon form. Okay. So the question is, what is the type of the solution? So we have arrived at the echelon form here. So we have arrived at the echelon form. This is our echelon form. Sorry, I don't have enough space. Okay, so here we have no contradictory equation. Contradictory equation. Okay, we have no contradictory equation. We have 0 equals to 0, which is true, no contradiction. But look, we have the linear system is in 4 variables, which are x, y, z, and w. In the first row, we have x leading. In the second row, we have y leading. In the third row, we have z leading. But in the fourth row, we don't have w leading. So what we have, there is a row where there is at least one variable that is not leading a row. So we have there is no row where w is, the variable w is leading. Okay, therefore when we have those conditions, we have infinitely many solutions. Is that okay? So to answer our question in this in this tutorial, we have just found that after the echelon form, or thanks to the echelon form, our original linear system of equations has infinitely many solutions. Is that okay? So this is going to be the end of our tutorial about Gauss's method. So this tutorial is made of 3 questions. And I divided them into 3 different videos so that the tutorial is not too long. So in the first video, in these 3 videos, or in this tutorial in total, we have seen the applications of the concept we have learned in the lecture. So here we have seen, we have applied, or we have seen how to perform Gauss's method, how to have the system in echelon form, and how to decide on the type of the solutions, mainly the 3 types, no solutions in the first video or in the first question of the tutorial, a unique solution in the second question of the tutorial, and in this question of the tutorial, we have seen how, thanks to the echelon form, we can decide, or we can see that the system has infinitely many solutions. So we will stop the tutorial here, and in the next video we will continue with the lecture. Is that okay? Thank you. Sorry, a quick correction here. Okay, here I meant to say -2, okay, rho 2 plus rho 4. -2 rho 2 plus rho 4. This is what we have done here. -2 rho 2 plus rho 4. Is that okay? Thanks.